Okay, good morning. Welcome to
FamilyMath154A.
I'll put our tetrahedron in the picture. So today we're going to talk about 3D printing and a really fun James Tanton problem. Have you ever heard of James Tanton before?
Yeah. I think he did that paper folding thingy that we did at the first Family Math.
Yeah, our Family Math number 1 was about paper folding. Remember when we folded up the
Paper and tried to set a world record?
We tried to set a world record. Yeah, so did he. I think they may have done it actually, although I seem to remember there was some controversy about it. I don't remember what the controversy was though. But anyway, so he also posts really fun problems on Twitter. And last week when I was heading up to Boston, he put this on Twitter. Find the surface area of the region formed by all points at distance 1 from a regular tetrahedron with sides having area 1. Or with, not sides, faces, I mean.
Yep.
Okay?
Yep.
What does surface area mean? Does anybody know?
Well, it means the area of this face plus the area of this face plus the area of this face plus the area of this face.
Okay, that's the surface area of a tetrahedron. What about a different kind of shape, like a sphere? What is the surface area of the sphere mean?
It means that it's what's on the outside.
The area of what's on the outside. Does that make sense?
Yep.
Okay, so as opposed to the volume,
Which is
you know, kind of like how much water could fill up in that.
Yep.
What's the area? What's the area of the outside? In this case, the triangle's on the outside. So you know what a tetrahedron is, right? We have one printed out right here, actually. What can you tell me about tetrahedrons?
Well, all the sides are equilateral triangles.
Okay, good. Hey, high five. All the sides are equilateral triangles. Anything else?
And all the sides are the same.
They're the same.
They're the same
yeah.
equilateral triangle.
They're the same equilateral triangle. That's good.
And it has 4 sides.
Yeah.
And it's kind of like a 3D triangle.
Kind of like a 3D triangle.
It's a pyramid.
Yeah, well, lots of neat things about these tetrahedrons. Anyway, so he said that the one thing that's not too hard to talk about. He said the area is 1. How do we find the area of a triangle?
It's 1/2.
Hey, brother, do you know?
1/2 base times height.
1/2 base times height. Okay, so here we have the base, say, and we just have to figure out the height. How do you think we're going to do that?
Well,
You could,
when you draw the line for the height, it splits it into 2 right triangles.
which is, you can use the Pythagorean theorem.
Yeah, and then we'll just use the Pythagorean theorem, and we'll figure out the formula for the area of a equilateral triangle. And that'll be kind of fun. Not really the main point of what we're trying to do today, but it's one part of this. You okay?
Yeah.
So instead of dwelling on that, we're going to start talking about not how we could calculate the surface area, because that might be a little bit tricky.
Yeah.
Because we've never even really talked about geometry, right?
No.
We're just going to try to figure out what this shape is. So what's your first thought when you see this problem? Finding all points a distance of 1 away from this shape.
You could try some circles with diameter 1 and like put them on it.
With diameter 1?
Radius 1.
Radius 1, okay. What's your first thought?
Well, I don't really know.
Okay. Well,
Problem.
let's look at it, let's go to a second movie and look at it from the point of view of a triangle instead of a tetrahedron, because maybe that'll be a little bit easier.
Yep.
Okay?
All right.